So welcome to Everyday Mathematics. Today we are on the MIT Integration Bee Semifinals, number 1 of the 2026 B, and we'll be looking at problem number 4, okay, which is the floor function or the floor of the integral from x equals to 0 to x equals to 2 of 100 times open bracket square root of negative 4x squared plus 8x plus 16 minus the square root of negative x squared minus 2x plus 9. So this is interesting. It's a monster of a problem. It's going to take us a while to solve it. There are two methods that we use to solve it. I will begin with the longer method, and then I'll show you the shorter method that's more of a geometric approach to the problem. So without much ado, let's jump on to the solution to the problem. So let's extract the integral itself and forget about the floor function for a minute. And so this is the integral from x equals 0 to 2 of 100 times open bracket square root of negative 4x squared plus 8x plus 16 minus square root of negative x squared minus 2x plus 9. So here I can pull 4 out. The square root of 4 is 2. And so we have negative x squared plus 2x plus 4 in the first term here. So I separate them into two separate integrals, and the 2 here multiplied by 100 becomes 200 as a factor here, as a constant, and then we remain with 100 here in the second integral. One thing I could do is pull out the negative sign within the square root sign of the first, and so we have x squared minus 2x minus 4 here, and then we have x squared plus 2x minus 9. Do some little bit of factorization. X squared minus 2x is the same as x squared, x minus 1 squared minus 1, and then this minus 4 here is brought here, and here x squared plus 2x is the same as x plus 1 squared minus 1, and then minus 9 as shown here. And so this becomes x minus 1 squared minus 5, and then x plus 1 squared minus 10. Then there's a negative sign here. So then I could allow the negative sign to propagate inwards, so that we now have the integral from x equals 0 to 2 of square root of 5 minus the square of x minus 1 squared. And then here we have 10 minus, under the square root sign, x plus 1 squared. So I could do a trigonometrical substitution. In the first instant, I'll just, before that, let's color code our integral so that we know. The first one is 200 times the integral from x equals 0 to 2 times the 2 of square root of 5 minus the square of x minus 1, and the second one is 100 times the square from x equals 0 to 2 of the square root of 10 minus x plus 1 squared. So here, in order to factor out, I could substitute. I could say let x minus 1 be the square root of 5 sine theta, right? So that now dx d theta is the square root of 5 cosine theta, and so we can substitute dx with the square root of 5 cosine theta d theta. And then the limit when x equals to 0, as you can see, 0 minus 1 is negative 1, and that means that negative 1 is equal to square root of 5 sine theta, and therefore theta is the arcsine of negative 1 over square root of 5 theta, and this negative can propagate outwards, and we can just say theta equals to negative arcsine of 1 over square root of 5. The upper limit when x goes to 2, it means that x minus 2 minus 1 is 1, so we have 1 equals to square root of 5 sine theta, and therefore theta is the arcsine of 1 over square root of 5. Then let's again do the same thing for the second integral. I'll choose to use the same variable theta, but in this situation I would say let x plus 1 be equal to square root of 10 sine theta, right? So with that in mind, dx d theta is square root of 10 cosine theta, dx is equals square root of 10 cosine theta. And when x equals 0, we have 1 plus 0 equals to square root of sine theta, and therefore theta equals to the arc sine of 1 over root 10. When x equals to 2, it means that 3 is equals to root of 10 sine theta, and therefore theta is the arc sine of 3 over root 10. So we substitute everything in there, and what we see here is that 5 minus 5 sine squared theta is square root is cosine theta times cosine theta. Here we have cosine squared theta, right? And note, in place of dx we place root 5 cosine theta. In place of dx here we place root 10 cosine theta. So our problem has collapsed into something more tractable. And root of 5 coming from here, with root of 5 here we have 5 here. So 5 cosine squared theta, and here we have root of 10 times root of 10, we have 10 cosine squared theta. Limit here, arc sine 1 over root 10, arc sine 3 over root 10, and here limit negative arc sine 1 over root 5, upper limit arc sine 1 over root 5. Okay, so that's important for us. So with that in mind, one thing we want to use, an identity that's very important for us, is we know cosine squared theta is the same as cosine 2 theta plus 1 over 2. So where we see cosine squared theta, we're going to plug in cosine 2 theta plus 1 over 2. And what that means for this place here, we have 200 divided by 2 is 100. 100 times 5, we have 500. So that's the over 2 part. And then we have cosine 2 theta plus 1 inside the integral. Same thing here. We do a 500 times the integral from arc sine of 1 root 10 to arc sine of 3 over root 10 of cosine 2 theta plus 1. So integrating cosine 2 theta becomes half sine 2 theta. Integrating 1 becomes theta, and applying the limits as shown there. Same thing here. We have half sine 2 theta plus theta, and then the 500s remain there as shown here. So for this part here, we have half sine twice arc sine 1 over root 5 plus, in place of theta, we have arc sine of 1 over root 5 minus half sine twice negative 2 arc sine of 1 over root 5 for the lower limit minus and obviously this minus here, arc sine of 1 over root 5. Same thing we do for the green integral, with the lower limit being arc sine 3 over root 10, lower limit arc sine 1 over root 10. So as you can see here, this negative here propagates out, becomes a plus, so we add this and this, so we have twice of the maybe let's not do that, but let's just explicitly show that this negative here propagates out. So the negative has propagated out, and then we have a negative here as well, and these negatives go out, so we have a plus plus. And so and at the same time we are going to bring this to this side, but before that, let's just consolidate whatever we've done in the blue integral. Okay, so with that in mind, we've just added these two since they're going to be the same. So we have half and half becomes 1, so sine twice arc sine of 1 over root 5, and then this and this adds up. We have twice arc sine of 1 over root 5. And then we can bring this half here on this other side. Half sine of twice arc sine of 3 over root 10 minus half sine twice arc sine of 1 over root 10 plus arc sine 3 over root 10 minus arc sine 1 over root 10. Okay, this is important for us. So we have 500, and then we can use sine 2x is same as 2 sine x cosine x. So that's what we're doing here. We have twice sine of arc sine 1 over root 5 cosine arc sine 1 over root 5 plus 2 arc sine of 1 over root 5. Same thing we may be able to do here. Half times 2, so that cancels out. That's why we have a 1 here. We have sine arc sine 3 over root 10 cosine arc sine 3 over root 10 minus sine arc sine 1 over root 10 cosine arc sine 1 over root 10, and then arc sine 3 over root 10 minus arc sine 1 over root 10. So this is 2 times sine of arc sine. We just get 1 over root 5 down here, and then cosine is square root of 1 minus sine squared of a function. So we have 1 minus 1 over 5, and then we have twice arc sine 1 over root 5. Again, we do the same here. Sine, we just pull out the 3 over root 10 here, and then since cosine is a square root of 1 minus sine squared theta, we have 1 minus 3 over root 10 squared, which is 9 over 10. Same thing for this part here. We have 1 over root 10 times the square root of 1 over root 10 squared is 1 over 10. And we remain with this. So since this is what we have now, this becomes now twice 1 over root 5. 1 minus 1 over 5 square root becomes 2 over root 5, and this part just remains like that. And then here 1 minus 9 over 10 is going to be 1 over 10, square root becomes 1 over root 10, and here 1 minus 1 over 10 is 9 over 10, square root is 3 over root 10. This part remains like that. So as you can see here, these two cancel out, these two parts here, and so we are left with now 4 over 5 plus twice arc sine 1 over root 5 minus 500, and these two terms remain, arc sine 3 over root 10 minus arc sine of 1 over root 10. Okay, so we can now multiply this by this. We have 400 times 500. We have twice arc sine of 1 over root 5 minus arc sine 3 over root 10 plus arc sine of 1 over root 10. So we're going to see how this can be evaluated. The first thing I'll do is I'll split this twice arc sine 1 over root 5 into 2, and one will interact with this and the other one will interact with this. Okay, so we have 400 plus 500 times arc sine 1 over root 5 minus arc sine 3 over root 10 plus arc sine 1 over root 5 plus arc sine of 1 over root 10. Okay, so what we see here, we see that arc sine 1 over root 5 minus arc sine 3 over root 10 can be, let's group that into one thing. Let's call this A. And then the second combination as B. And that's what we do. So if A is equals to arc sine 1 over root 5 minus arc sine 3 over root 10, then it means that the sine of A is equals to sine of arc sine 1 over root 5 minus arc sine 3 over root 10. And then if you have sine of a difference of two items is the same as sine of the first times cosine of the second minus sine of the second times the cosine of the first. And that's what we've done here. And so sine of arc sine, this just remains 1 over root 5. Cosine, since cosine is the same as square root of 1 minus sine squared of sine squared, that means that we're going to have a square root of 1 minus 3 squared over root 10 squared, which is 9 over 10. And so that's what we're going. So sine A is equals to 1 over root 5 times square root of 1 minus 9 over 10 minus sine of arcsine is a 3 over root 10 times here again square root of 1 minus 1 over root 5 squared, which is 1 over 5. And so sine A is 1 over root 5 times 1 over root 10 minus 3 over root 10 times 2 over root 5, which is, so the denominator is going to be root 50, and that is 1 minus 6, which is negative 5 over root 50. So A is the same as the arcsine of negative 5 over 50, which is the same as negative arcsine of 5 over root 50. Say the second part is B. Again, we do the same with B, and so sine of B is the same as the sine of arcsine of 1 over root 5 plus the arcsine of 1 over root 10. And since sine of a sum of two numbers is the same as sine of the first times cosine of the second plus sine of the second times cosine of the first, and we're just going to do the same thing, and this boils down to a scenario where we have sine B is equals 1 over root 5 times 3 over root 10 plus 1 over root 10 times 2 over root 5, which means the sine B is equals to 3 over root 50 plus 2 over root 50, which is 5 over root 50. And therefore B is the same as the arcsine of 5 over root 50. Therefore, A plus B is equals to negative 5 over root 50 plus 5 over root 50, which is 0. And that means our integral now is just going to be equal to that first constant 400, and therefore the flow function of that integral that we looked at, since a flow function means the integer lower than a number, but if the number itself is an integer, it remains to be that same number. So 400 remain as an integer means that 400 is going to be our answer. So that is the first way by which you have been able to solve this problem. Very interesting, requires a little bit of mental focus. But let's look at the second method, which I think would have been the faster method to solve this problem. So for this problem, we extract our integral, and we do the same thing that we did in the first, pull out the 4, so we have the 2 here, we have 200, we separate into two separate integrals, and then we consider this to be the first integrand y1, and then this is the second integrand y2. Now y1 is the square root of negative x squared plus 2x plus 1, therefore y squared is the same as negative x squared plus 2x plus 4, and that means that we can formulate this into an equation over a circle where the center is 0, is negative 1, 0, and then the radius is root 5. And the same thing would happen for the second one, and we square y2 is equals to negative x squared minus 2x plus 1, and that means we have a circle whose center is negative 1, 0, and the radius is root 10. Okay? So if that be the case, we have y1 where y1 is the positive half of the circle at the top, but we're integrating it from 0 to 2. And so if this be our circle, the area of interest is going to be equal to this area here. And that means that since the height to the circle at 0 and at 2 is the same as is 2, 2, we're just going to calculate the area of these two triangles and then this sector here. So the integral y1 is just going to be equal to twice the area of the triangles, half times base, which is 1, times height, which is 2, plus the area of the sector, which is pi minus 2 arcsine of 2 over root 5, because this angle here is going to be the arcsine of height 2, the hypotenuse is root 5. So we are going to have two of these angles, and the entire angle is pi, or 180 degrees. So we have pi minus twice arcsine of 2 over root 5 over the entire angle of the circle, which is 2 pi, times the area of the circle, which is pi times r squared, which is pi times root 5 squared. So we've calculated the area of the sector, and we've added the area of the two triangles. We can simplify that. Half and 2 go, so we have just 2 remaining here, and then dividing everything here, we have 5 pi over 2 minus 5 times arcsine of 2 over root 5. So that's the area. As simple as that. It was very quick and easy to obtain. So for the second integral, we're integrating y2, and we know what y2 is, the square root of negative x squared minus 2x plus 9, and that is our circle. And what that means is, since the center is negative 1, 0, we're calculating the area from 0 to 2. And so this is the area that we're calculating. And that means it involves calculating the area of this trapezium, and then the area of this sector minus the area of this triangle here. Okay. So in other words, the area that is covered by this circle y2 is the same as area of the trapezium, area of the sector minus the area of the triangle, this triangle here. And the area of this triangle is the same as the area of the bigger triangle here minus the area of the smaller triangle here. Anyway, so area of the trapezium is a half a plus b times height, which is a half, and this from here to here is 1, from here to here is a third, times the height, which is 2, and then the area of the sector is this angle, total angle from here to here, which is arcsine of height 3, hypotenuse root 10. So arcsine of 3 over root 10 minus arcsine 1 over root 10 over 2 pi times the radius, which is root 10 squared, minus the area of this big triangle is a half times 1 times height, which is 3, minus half times 1 times a third, which is the height. So we have 1 plus this half and 2 go, we have 1 plus a third, and then pi and pi goes, so we have, and then 2, so root 10 squared is 10, 10 divided by 2 is 5, so we have 5 arcsine 3 over root 10 minus 5 arcsine 1 over root 10 minus 3 over 2 plus 6. A 6 plus a third is a half, so a half minus 1 over 1 and a half becomes negative 1, negative 1 and this 1 becomes 0. So our answer really is 5 arcsine of 3 over root 10 minus 5 arcsine of 1 over root 10. And that is the area of the second circle. So now we have to combine things together. So now our problem was 200 times the first area minus 100, the second area. And so the first integral was twice plus 5 pi over 2 minus 5 arcsine 2 over root 5 minus 100, 5 arcsine 3 over root 10 minus 5 arcsine 1 over root 10. We can multiply 200 across, so we have 400 coming from 200 times 2, and then 200 times 5 pi over 2 is 500, and then we pull out everything and we say this is pi, and then this 5 times 200 is 1000, but we'll keep the 2 here. Same thing here, the 500 here has been pulled out, so we have pi minus 2 arcsine 2 over root 5 minus arcsine 3 over root 10 plus arcsine 1 over root 10. We have 400 plus 5, and so we can now say let one of this arcsine 2 over root 5 interact with the 3 over root 10, and that's why we have a negative here, and we have bracket arcsine 2 over root 5 plus arcsine 3 over root 10, and then plus arcsine 2 over root 5 minus arcsine 1 over root 10. And then so it's important to note here that 2 over root 5 is very close to 1, so when you add anything extra, it's going to go across the pi over 2 threshold, and that's why now we have pi over 2 introduced here, arcsine of 2 over root 5, square root of 1 over 1 minus 9 over root 10, again using the formalism where a sine of 2, the sum of two numbers is a sine of the first times cosine of the second plus cosine of the first times the sine of the second. And that's what we're doing here. The same simple trick we're doing here. And as you can see, we have pi minus pi over 2 arcsine of 2 over root 50 from here, 3 over root 50 from here, arcsine, the same thing, difference of two numbers, arcsine 6 over root 50 minus 1 over root 50. And that becomes 400 times 500 times pi minus pi over 2 arcsine 5 over 50 plus arcsine 5 over 50. And these are same thing, so we just bunch them as twice of that. And 5 over root 50 means that 50 is 25 times 5, so square root of 25, so 50 is the same as 25 times 2, so square root of 25 is going to be 5. 5 comes out, 5 and 5 cancels out, so we're going to be remaining with 1 over root 2 from this. And this is a popular thing. Arcsine of 1 over root 2 is pi over 2. So 2 times pi over 2, not pi over 2, but pi over 4. So 2 times pi over 4 is going to be pi over 2. Pi over 2 times pi over plus pi over 2 is going to be pi. Pi minus pi is going to 0. So this second part collapses, and we're just left with 400. And so leading us to the final answer, which is the flow function of the integral, which is 400. This 400 was what we got from the integral. So that, I think, could have been a very fast method to use. Both methods are sound, but I would have chosen to use the second method because it's straightforward and quick. So without much ado, I'd like to thank you so much for staying tuned. If you have a question on any of the steps that we undertook, feel free to reach out to us. We are excited always to share our interest and passion when it comes to mathematics, and hopefully that kind of is evident and we can share with you. So until next time, bye bye.